So in Markov decision process, we will be discussing how agent will make the decision so that whatever it wants, it will get it. Okay. So the how the agent will be taking decisions here so that it will get whatever it wants. So here, what is that in this decision theoristic agent? This depends upon utility theory and probability theory. These two will be combined here, students. The utility theory and probability theory will be combined to take the decisions. Okay. So in the previous chapter, we have discussed that the decisions will be based on only the probability theory. Okay. Now here the utility theory is also used to take the decisions. Okay. So that is why the agent that depends upon the decisions of that agent depends upon utility theory and probability theory. Then that agent is called the theoristic agent. The agent is called theoristic agent. So this agent will be taking the decisions. That is rational decisions means the decisions are perfect decisions. Okay. So that gives you the maximum solution. Okay. So it will be taking the rational decisions and this rational decisions will give you what? So this rational decisions will be based on whatever knowledge it has and whatever the goal it has. Okay, this agent will be taking the rational decision, whatever it wants and whatever knowledge it has. Okay, based on that, it will be taking the rational decisions. So here, the agent make the decisions in the uncertain environment wherever and it is having conflicting goals also. Okay, this theoristic agent will be able to take the decisions in uncertain environment and wherever it is having conflicting goals. For example, if you see that self-driving car, okay. So whenever the car is on the road, self-driving car is on the road, so there are more number of conflicting goals. More people will be crossing the car, okay. So some people will be overtaking, and there are some junctions like that. There are conflicting goals. And what type of environment it is? It is uncertain environment because the profit cannot be predicted. No, so what type of environment here is uncertain environment. This theoristic agent, this agent, what is this agent? This agent depends upon utility theory and probability theory. It will be taking the decisions. So this theoristic agent will be able to take the decisions properly in uncertain and wherever it is having conflicting goals. Whereas if you see the logic agent, so logic agent will not be able to take the decisions here and it will be struck. Okay, so that is the advantage of this theoristic agent. So now we will be discussing, we also discussed that the goal-based agent. So this agent will be having a goal, yes or no? So this goal-based agent will be distinguishing the goal state and non-goal state by using binary distinction. Okay. So whenever it is reaching the goal state, it will be assigning value 1. Whenever it is not reaching the goal state, it will be assigning value 0. So the binary distinction will be used for goal state and non-goal state. Whereas, so because of that, since it is binary, so that what happens, it will be sometimes it will be struck. Okay, whenever it has to take the decisions, it will be struck. So whereas this decision theoristic agent we have discussed, no, this will be continuously measuring the state qualities, whatever different states we are getting. So what is uncertainty here? The environment will be changing with respect to time. Okay. So means that every time we will be getting different states. Okay. So what is this decision theoristic agent will do here? It will just continuously measure the state quality because the states are changing every time so that it is able to take the decisions. Okay. So this is about the introduction part of Markov decision process. Now we'll discuss what are the combining beliefs and desires under uncertainty. So we have discussed that this decision theoristic agent will be able to take the decisions under uncertain environment. Now we'll discuss what are the beliefs and the desires we have under uncertainty. Okay. So the agent here, what it has to do, it has to have the preference between the different states. What is that? A world is nothing but environment. Okay. So the environment will be changing every time. Whenever some action is performed, what is that here? We will be getting different states. Okay. So the agent has to take any one of the states. Okay. So that will be captured by the utility function. How it will be preferring the states here? It will be preferring the states by using utility function. So this utility function is what? It is a function that assigns the single number to each and every state. Okay. So whenever some action is performed, we are getting set of states. What is this utility function will do? This utility function will assign the single number to each and every state. Okay. So this utility is usually combined with the probabilities, outcome probabilities of action to give the expected utility for each action. Okay. So what is utility here? The utility is assigning the value to each and every state. Okay, this value utilities will be combined with outcome probabilities of actions. For every action, we will be having what is the probability of getting particular state, yes or no. So the utilities will be combined with the outcome probabilities to give the expected utility for each action. Okay. So here we will discuss what is that. So how do we denote this here? So we denote it as U of S. U of S is the notation we use to denote the utility of status according to the agent that is making the decisions. Okay. So here this is students. So it is uncertain environment. Whenever some action is performed, which state to be considered? Okay. So whether it has to consider A, B, C. We have three different states. Okay. So decision should be taken which state to be considered. Okay. So what is here in probabilistic model? What is that we will be doing? We will be adding the probability also to each and every state. Based on the probability, the decision will be taken. Okay. And we have discussed that what we are assigning some value to each and every state. Okay. So if you just see this example, student, so the value 100 is assigned to S1, the value 50 is assigned to S2, the value 70 is assigned to S3. Okay. For each and every state, some value is assigned. Okay. So, and these are called utilities. What are the utilities here? 100, 50 and 70 are the utilities. Okay. Now what is that here? We are also, the agent is also assigning some probability to each and every outcome. Okay. So what is the probability of getting S1 is 0.2. The probability of getting S2 is 0.7. The probability of getting S3 is 0.1. Okay. So these are the outcome probabilities for these states. Okay. So what is that here? So this is S0 is the initial state. By performing some action A1, action A1 is performed. Okay, by performing this action, we are getting different states. What are the different states we are getting? S1, S2, S3. Okay. Now what is that agent has to do? The agent has to select any one of this state. Okay. How agent will be selecting any one of this state here? Based on expected utility. What is expected utility? Expected utility is nothing but combining the utilities with the outcome probabilities. Okay. So we have to multiply these two terms. You have to combine the utilities with the outcome probabilities. So what is U of S here? The U of S will be U of S naught will be 100 into 0.2, 50 into 0.7, 70 into 0.1. Okay. So by just adding all these product terms, we will be getting the value 62. 62. So what is 62? This is the expected utility of this particular action. If this action is performed, what is the value assigned to this action is 62. Okay. So what is that we have done? We are combining the utilities with the outcome probabilities. of action to give the expected utility for each action. Like that, we will be finding expected utility. Okay. Now, what is the notation we use here? U of S is the notation we use to denote the utility of state S. Okay. According to the agent that is making the decisions. So, what is U of S is the utility of state S according to the agent that is making decisions. Okay. Now consider the states as complete snapshot of the world. Okay. So what is that? Here we are getting different states as time is changing. Okay. So we'll be having different states. So this complete all states we have considered, all the states we have considered as complete snapshot of the environment. Okay. So, for example, if a non-deterministic action, so if non-deterministic action means what? You cannot predict what will be the outcome. Okay. So, that particular action is called non-deterministic action. If a non-deterministic action A is say if action is performed. So what happens here? We will be getting set of possible outcomes. So here we have discussed if the action A1 is performed, what are the possible outcomes we got? S1, S2, S3 are the possible outcomes. Yes or no? So here also, if some action is performed, it will be having set of possible outcomes that will be denoted as result I of A. So that is S1, S2, S3 we have taken. No? So that we denote it as result I of A. What is I here? I is the range over different outcomes. Okay. So what are the outcomes we are getting by performing that particular action? That is denoted by I. So it is the range of the different outcomes that we'll be getting. Okay. So here, what is that agent has to do? Before executing A, before executing A, the agent has to assign the probabilities to each outcome. So here we have discussed, no? So see this example, students. Here for each outcome, the probabilities, what are the probabilities here? 0.2, 0.7, 0.1 are assigned, okay, to each and every state. Okay. So this should be assigned before execution of A itself. Okay. So here what is that? Probability of result I of A given do of A, comma evidence. Okay. It means that what is here is E indicates the agent available evidence about the environment. Okay. So it is agent available evidence about the environment. Do of A is what? Do of A is the action that is executed in the current state. What is the action that is executed in the current state? That we denote it as do of A. Okay. Then the expected utility of action given the evidence. What is the expected utility? How do we find out? The expected utility will be found by just combining the utility with the probability. Okay. So we have to combine the utility of each and every outcome with its uh, outcome probability. Okay. So that we denote it as E of A given E. Okay. So how do we find out? It is the probability. Okay. What is the probability of each and every outcome here? So it is the probability of result I of A given Q of A and my evidence, okay, into the utility of for each and every outcome we are assigning some value. No? That is nothing but utility of result I of A. Okay. So we have to add all these product terms that we will be getting what is the utility of particular action. That's what we have discussed here, students. Here we have see this slide, all of you. We have S naught. S naught is the initial state. So we are performing different actions on S naught. If you perform action A1, okay. So these are the three outcomes. For example, if you perform action A2, see this slide, all of you students. If you perform action A2, okay, what are the outcomes we'll be getting? We are getting only two outcomes. Okay. So that is S2 and S4 are the two outcomes. Then here we found what is the utility function for A1, the utility function for A2. The utility function for A1 denoted as U1. The utility function for A2 is denoted as U. Okay. So A1 value is 62 whereas A2 value is 74. Okay. Now the agent, so if you are performing two different actions, we are getting two different values. So now the agent has to take decisions which action to be considered. Now agent has to take the decision which action to be considered. How it will be taking the decisions here? It will be taking the decisions based on this expected utility value. Whichever action is having maximum expected utility value, that particular action will be considered. Okay, so that's what we have discussed here also. So that is calculated like this. Now, what is principle of maximum expected utility? The principle of maximum expected utility is that the rational agent should choose an action that maximizes the agent's expected utility. Okay, so now which action to be considered here? That that particular agent, okay, which action to be considered here? That is maximum expected utility. Okay, means that which action is giving maximum value, maximum utility value. That particular action will be considered here. Okay, so now what is that maximum expected utility principle defines? So the right action to take in any decision problem. So this maximum expected utility principle is that the agent has to take right action to take many to take in any decision problem. To take any in decision problem. Okay. So the computations here involved will be prohibited. So there are more number of computations. Okay. And it is sometimes difficult even to formulate the problem completely. Okay. So it is always difficult to formulate the problem completely. Okay. So that is the principle of maximum expected utility. So the agent will select an action which is having maximum expected utility. Okay. So then it is also we also require what is the initial state. How do we get the initial state of the environment? Initial state of the environment requires perception, learning, knowledge representation, and inference. Okay, so these are the things it is required to know the initial state of the whole. Okay, that is perception, learning, knowledge representation, and inference. Okay, now we are computing what before execution of action A itself. What is that agent? What is that? What is that agent is doing? Agent is assigning the probability values. Okay. So to compute this probability values, agent, what is that required here is the model, whatever we have designed should be complete causal model of the environment. The model we have designed is complete causal model. Should be causal model means what? Whichever whichever is responsible for cause and effect, that node will be considered first. Then the nodes which are affected by the first node will be considered next. Okay. So that is called causal model of the node. And NP hard inference in Bayesian networks. And it is also required NP hard inference in Bayesian network. What is NP here is non-deterministic polynomial. Okay. Now, computing the utility of each state, your result I of A often requires searching or planning because agent does not know how to be a state until it knows where it can get to from that state. Okay. So what is that here? The agent is assigning some value to each and every outcome. That is one utility I told you. So assigning some value to each and every action requires what it has. It requires searching and planning properly. Okay. So otherwise it is not possible to assign the value to each and every outcome. Now, and it is also requires from which state the agent is reaching to that particular state. Okay, the state from worst state to good state it is reaching, then it is a good option. Otherwise, it is not good option. Okay, so the agent is written to that state from which state, that should also be considered here. Okay. Now the decision theory is not a solution that solves a problem. On the other hand, it does provide a framework into which we can see where all the components of a system fit. Okay. So what is decision heuristic? The decision heuristic agent is not a solution. It is not a solution to solve the A problems. Okay. So what is that here we have done? So uh, it does the provide, what is that here it does provide is it does provide the framework into which we can see where the components of AI system fit. Okay, so it gives you the framework to which the AI system, the components of AI system is the AI system will be fixed.